you're in the back over there, Ben, can you hear me? Cool, awesome. All right, how's everybody doing tonight? Great. Yeah, we got some good food, good people in the room. What else could we ask for? Cool, well thank you so much for coming out. My name is Pablo Casalimas. I'm a co-founder and managing partner at 161 Ventures. We're an early stage VC fund with offices in Miami, New York, and Seattle. And we specialize in doing one thing better than most firms. We host really great events, helping companies get in front of customers, raise money, and really scale. So thank you. Thank you. So really excited to be in Atlanta. This is our first event that we're hosting in the Atlanta ecosystem, and I've been hearing great things about it. You know, we have Jack in the room from Cox Ventures. They do great work over here, and super excited to be here. So I want to give a special thank you to some of our sponsors who made this possible. So Menlo Park Patents, they were not able to be here today, but they're a sponsor. If you need a patent, if you're interested in getting a patent, they're doing it at half the price of typical law firms, and they're doing it way better. They have industry experts on their team that can really help you navigate that process. So if anybody wants to learn more about that, come up to me after. I'll be happy to make an introduction or share more about Menlo Park Patents. And then I want to give a special shout out and call up our good friends from Cielara who have flown in from New York and Seattle to be here with us. And they're really helping a lot of companies save on their cloud spend. So if you want to come up, Jaron, and give a quick blurb on what you guys are doing, give it up for Jaron.
Thanks, Pablo. A round of applause for Pablo for putting this together real quick. I'll keep it super short because I know we want to get to the panel. But you know, Cielara, we help you save on your cloud spend flexibly through commitment insurance. We're the category creator for this. So if you're on AWS, Azure, GCP, you want to save on your Kubernetes or GPU workloads, we can do so with a 30-day commitment, help you save 30% on your cloud bill. If it sounds too good to be true, or you want to learn more, my team's here as well. Come find us sometime during the event, and glad to chat with you. Thank you.
Thank you so much for your support. Awesome. So without further ado, we have some incredible speakers lined up. I'm going to let them introduce themselves because their backgrounds are so impressive. I could spend 10 minutes just introducing them. So if you're speaking on the panel, please come up, and we'll go ahead and kick off this exciting session. Give it up for our panelists.
Absolutely. Oh, actually, you're on the side. Go ahead, man.
I'll sit there.
Okay.
And I'll give you that.
Hi, everybody. My name is Joe Beda. I'm, let's see, my career started at Microsoft. I ended up at Google, did GCE, helped found GCP, and then did Kubernetes, and started this startup called Heptio. We sold to VMware, and about 3 years ago, I decided to take a break, and so now I'm semi-retired. So trying hard not to have a real job. So that's where I'm at right now.
My name is Hasibul. I started my career in Microsoft like Joey, and I knew his co-founder of Heptio into the same places in Microsoft. He was a PM and I was a developer, and I was original dev lead for Azure Management API back in 2009 when Azure was not Azure, it was a Hedgehog. Then after building Azure for 3 years, I decided to go into a listed startup, build the first generation of identity access management solution, sold it to CyberArk, decided to go back to VMware, bring VMware to cloud and container. So I was actually a Cielara employee that was get acquired by VMware and build the NSXT for all the cloud and container back in 2015 to 2019. Then I decided to go back to a hyperscaler, creating problem to be a consumer, become a head of engineering at Uber. And I hated my job for 5 years because I needed to run a platform that support 20 million QPS. And from that pain, I decided that, okay, so if I build something that will be solving the problem, not creating another problem on the tooltips, and that's how I started Cielara. And yeah, that's more or less my journey.
Hey everyone, my name is Florian Berchtold. I'm principal software engineer at Zipline. Our company is a logistics company. We do life-saving deliveries in Rwanda and Africa, and started our doorstep deliveries for Walmart in Dallas this year. And I'm the head of the developer productivity team at Zipline. And as a side gig, I run our data center. And that's where, as a software engineer, not a network engineer, once I heard about Hedgehog and how they can help me with running spine leaf topologies and through Kubernetes, I was like hooked immediately. So yeah, I'm a big fan.
Okay, and your story's a little sexier than that, right? You're not just a logistics company, but these are like drone deliveries, right?
Yeah, I mean, we call ourselves a logistics company because it's much more than just having a fancy flying drone in the air, but we have two different drones. We have long-range drones that fly in Africa, do deliveries like in a 3x3 yard area, 10x10, whatever. Don't quote me. And like we just released another kind of amazing story about like 120 million plus miles flown, fully autonomous. Like we're the biggest drone operator in the world, and we just had another story where there was a woman in Africa, I think it was Rwanda, she gave birth to twins, and they needed blood supplies, and the nearest blood support, which is like, I don't know, 50 miles, 60 miles away, was 5 to 6 hours by car because of the infrastructure. So it took 120 seconds from ordering to the drone is in the air, and another, what was it, it got a lie, 30 minutes to deliver the supplies at that place. So it's really amazing to work at a company that saves lives every day. And what we do now with Walmart in Dallas is we have those quad pentacopters that fly over your head, lower down a small delivery drone, and people really don't, like they're really blown away with that experience. We had our whole executive team down in Dallas like over the whole weekend, and they come back, and I asked them on all hands, I was like, can you share a little bit about the excitement? And they were like, Flo, sorry, it's almost impossible. This is so amazing. Like they talk to people, the fact that you can now rely on getting your baby formula delivered in like 5 to 10 minutes without leaving the house. It's like it really adds some quality, serious quality. So, and back to the technical stuff. We use models, of course, AI for object detection and avoiding trees and whatever. And we have on-prem data center. We do some machine learning, recognition, semantic segmentation, all the non-LLM stuff, right? So our GPUs are much, much smaller, and the models are teensy-tiny compared to 70 billion parameter files, models. But yeah, it's very exciting, and it's a huge impact.
Great. And I'm Marc Austin. I'm your moderator tonight, so this is the esteemed panel. And I am co-founder and CEO of Hedgehog. So we are AI network software, and we're here at KubeCon because look, software-defined networking has been around for a long time. What we do that's sort of fundamentally different is we turn Kubernetes into a network controller, and our goal is to deliver a cloud-native user experience that can be used by all the people that are at this conference. So, on that note, I will make the disclaimer that some of these questions will be a little bit angled toward network, but my hope here is that we have a really good discussion. Hopefully these guys talk to each other and not to me, and everybody learns a little bit from that. Sound good?
Sounds good.
All right, so I'm going to kick it off with you, Joe, because
Should we sit down?
yeah, let's sit down.
Otherwise, I'm going to get tired of standing
Yeah,
here.
well, your knees might lock out, you might faint, all kinds of things could happen. So, okay, so we're here at KubeCon. You're wearing the 10-year anniversary shirt. I don't even know how many years is it now?
I don't know. I'm bad at this stuff.
Okay, but you were one of the founding members of Kubernetes, right?
Yes.
Okay, cool. So thank you. You gave us all a great platform. You created a great community. I guess just baseline,
however many years ago it was, when you and your colleagues started working on Kubernetes, what problem were you trying to solve? What was your design goal for the project?
Yeah, so I started this other project called Google Compute Engine. And at the time when I started GCE, nobody at Google was using VMs. And I remember we were this crazy team up in Seattle, and Google is fundamentally a passive-aggressive company. And so the idea is that they, let you do your thing and, only, pass judgment when you actually want to ship, right? And so we were left alone, and we got to the point where we were actually able to run VMs on top of Borg, these sort of precursors or a container system at Google. And I got to the point where we had a VM up and running, and we could SSH into it, and I showed it to my director, and he was unimpressed. And the reason being is that inside of Google, the whole goal is to run workloads, not to actually run virtual machines. And so after we did GCE and got that going, there were a group of us that were like, okay, let's solve the next problem. And the next problem is like, okay, you have a place to run stuff. How are you going to manage that? What are you going to run? How are you going to do it? And at the time, Docker was taking over the world, and everybody was super excited. And we're like, okay, Docker's really interesting. We had the context of sort of a clusterized version of it with Borg, and we're like, it solves half the problem. The other half the problem is how do you manage this stuff across a set of computers instead of a single one? And so that really was the genesis of Kubernetes, of like, how do we take, a VM and be like, okay, now what? What are you going to do with the VM versus just having something you can SSH into?
Okay, and so, but it was really solving that problem of managing distributed cloud workloads.
Exactly, right. It's like, it's not, being able to access a VM is one thing. Being able to actually talk about your application and deploy it, connect it to the network, expose it to the world, that's the next level, and that was really the goal of Kubernetes.
Okay, so very firmly in the application space.
Exactly, yeah.
Okay, so my team and I came up with this crazy idea that, hey, why don't we use Kubernetes, which was designed for the application space, why don't we turn this thing into a network controller? Why would anybody ever want to do that?
Well, you tell me, but also, a funny thing happened on the way to actually building Kubernetes, which is, we learned a lot through Borg and through building GCE around how to manage APIs, how to manage control planes. And originally, Kubernetes was really focused on how do we deploy and manage containers, but we accidentally created a really generic control plane. This idea of resources, spec versus status, what do you want versus what do you have? Controllers that actually help to drive spec towards, your status towards the spec. And then Brendan Burns, one of the other co-founders of Kubernetes, early on introduced this idea called third-party resources that eventually got renamed to custom resource definitions, CRDs, which really took Kubernetes from about managing containers using these patterns to managing anything using these patterns. And so what we find is that whether you want to manage, what containers are running on a cluster, or eventually sort of like what members are on your team and applying that, or what resources you want to allocate in some sort of cloud with things like Upbound and the stuff they're working on. This pattern around, that had worked so well for containers could be applied to so many other different domains. And I think it's a natural fit towards being able to provide a network experience using a common API model that is, inherits a lot of the sort of sensibilities that you'll find in public cloud around sort of like, I want to create a network, I don't want to manage it, I want to configure it from the point of view of the end user versus the point of view of the network engineer.
Yeah, it's a great time to pass the mic to Florian. Okay, so Florian, you are a user, correct?
Oh yeah.
Are you a network engineer?
Not at all.
Are you a Kubernetes fan?
I love Kubernetes.
Okay.
All right.
So, let's see, it was a prior company actually, prior to Zipline, and you were doing kind of the same thing you've done at Zipline, right? You were building a private cloud.
Yeah.
Sort of, what did you need to solve, and how did you want to solve it?
Okay, so I started off purchasing used servers. We got it through some other acquisition that we did, and I was left with like 20 servers, 10 GPU servers, a little bit of storage, some control plane stuff, and I was like, okay, how do they have all these nice 2500 gig interfaces? How do I make them talk to each other? And then I mean, in this case, it was like Serve the Home that I watched, where they presented a Celestica C-Stone DX010 switch, which is like a, I don't know, 10-year-old hyperscaler 100 gigabit switch with 32 ports, and it was available on eBay for $500. And I was like, hey, yeah, I get one of these. It's apparently super easy because it runs Sonic, and I can do all kinds of fun stuff with it. And it took me a couple of weeks to really get behind the basics of like, okay, how do I configure the ports now? And I was really frustrated because I have no idea what is a port channel, and then how do I make those two switches now work together, because I get these spanning tree problems and like all.
You started running into network stuff.
Yeah.
Like the Arcana.
Network stuff, exactly, yeah. And I ended up with just running one switch, and I had up to 32 servers that I can connect to each other and have talk at 100 gigabit. I was like, yay. And then I kind of started with like, okay, how do I get high availability? How does it scale from here on? And I was left alone with like one switch. There's no way to scale these things with the knowledge that I have. So I started Googling, I found a few hints, and then I ended up with a YouTube video where you talked about, hey, let's run Kubernetes on the switch. And I was immediately like, yeah. I just learned about like I was 1 year into Kubernetes, and I was like, oh yeah, that makes total sense. I had no idea what's going on, what that actually means, but yeah, ended up reaching out, and then I was introduced to Clos, Spine Leaf, BGP, peering, like all the crazy networking stuff that's going on, and that was my entrance to networking.
Yeah, and so somebody in the audience earlier tonight asked me, what is a cloud user experience for an AI network? And I think it was you, Ganesh, right? And I said, well, you really ought to ask a user. So what is a cloud native user experience for operating an AI network?
So if you get a VM somewhere, GC, AWS, doesn't matter, all you care about is, I have that VM, I have a VPC that kind of defines a rough idea of networking domain. Maybe you care about a subnet, but then that's it. And then you have some security rules, and that's really it.
So there's an abstraction.
There's a very high level abstraction. Like,
and most people at this conference know that abstraction.
Ideal of infrastructure.
Correct. Yeah. So the thing is, you never worry about cabling, right? You don't worry about, oh, do I have like bonding and LSCP and this stuff? Like, no. I just say this instance, this subnet, done.
Yeah. Okay.
Yeah.
And that's what you get.
And that's what you get with Hedgehog, right?
Yeah. Okay.
My point is, it's not that trivial, of course. You need to have a basic understanding of, okay, you need 2 switches per rack because you want to have that high availability. You need to know a little bit about, okay, how do I connect my spine to my leaf? But then after you just wire things up, you take the wiring, and you end up with manifests in Kubernetes. So you have Kubernetes manifests that say, oh, server 1, port 1 goes to leaf 1, port 1, and the same server port 2 goes to leaf 2, port 1. And that's your connection. And then you tell it, oh, I need a VPC. Okay, you create a VPC manifest. And then, the VPC contains, of course, subnets. You start off with a subnet, VLAN 1000. You need an attachment. So you say, the connection that I just created, connect to that VPC, and that's kind of it. That's really the level of abstraction. I don't need to know about the pairing of BGP or what are the inter-spine leaf IP addresses. Nothing. I can really stay on a level where I, as a non-network engineer, can make sense of what I'm dealing with.
Okay, cool, thanks. All right, so you're in the drone delivery business, you're expanding really fast. We have another panelist here who was in a logistics business at Uber, right? Where you guys were expanding really, really fast. And Florian, you're gonna expand a little bit, right?
Yeah.
Okay. So this is sort of, I'm gonna pass the mic to you, Hasibul. So when Florian is planning his network expansion, what things does he need to think about? And what technologies does he need to do to plan for it successfully and sort of model the configuration outcome, you know, before he actually starts applying configuration to real infrastructure?
Two major things. One thing is he need to have a baseline configuration. So he kind of, that's actually a lot of work. Baseline configuration means you have a configuration that is vetted. That means you're following the best practices and all other kind of compliance, security, all other requirement. Second thing is also prediction. That means you are moving a workload, and sometime workload could cross boundary, and you need to have a prediction model. What is your capacity look like? And those are the two big things that actually hits at the last moment. And once you deploy, you cannot change either one of them. It actually breaks you.
Okay, and you have a product, I think, that generates a digital twin. Like when I was at Cisco before I started Hedgehog, and that was one of the things that we looked at really pretty closely, which is, okay, you know, how do you build a digital twin of a network, and then sort of do that kind of predictive analytics that you were talking about, sort of model changes before you apply configuration to the physical network. Can you talk a little bit about how you do that?
I think this is a very common concept everywhere. So I used to teach CCNA back in 2004, and then Cisco has that digital twinning concept. You configure everything before you deploy. And then it is being adapted everywhere else. That means you model it before you push it, and semiconductor and all other industry already adapted it. So some reasons the dev tools and the infrastructure space is still 20 years behind industry. We build the other technology, but we never solved our own problem. That's what it is start. So our entire philosophy, how do you solve the problem at a prevention stage instead of go through this entire life cycle of detection, remediation, logging and everything. That means, can you prevent everything? Can you predict everything? So in other way, like you have to model the your resources and what is the configuration and all the dependency it has. And if you think about the entire problem as a sense of a model and sensor, and it's already in the road, like a self-driving car. People feel safe to get in there, and everybody, we are using it. So it's a similar concept. You can model the life system, and then if you have that prediction engine available everywhere with the advantage of a self-driving car, causal AI, and LLM, you could make it a kind of a very cheap with everyone's hand. And then simple concept is you can make a digital twin, and if you have a prediction layer on top of it, you could break it, you could fix it, you could come out with 10 more mutation and figure out what is the right fit for you. And then you could actually deploy it. And the biggest change is mostly if we can give it to all the developers and think about that every changes you are making, you can simulate the change before it hit your production. That actually takes out your productivity by 50x, because every ticket you are filing, you have to go through this entire life cycle of the how do you kind of remediate it, either it is a network or it is an IAM or it is an application issue. Or every time you don't do it, you end up with one of the incident, either a big security incident, reliability incidents, or real production problem. Awesome. So that's the kind of only simple objective. So it's already exists, technology exists, we never apply into our own domain. We kind of build it for other domain.
Okay, so we were just talking about predictions. We were talking about predicting sort of infrastructure and configuration. How about predicting markets? It's harder, everybody likes to do it, but it's always fun. So we're here at the Cloud Native Computing Foundation event. And I didn't, it's funny, as I was preparing this question, I thought I was coining a term, but then I heard it today during one of the keynotes, which is AI native. So the question is this, is 10 years from now, and I'm going to pass the mic to Joe, since you've been at this for a long time, and everybody is going to make a prediction here, but 10 years from now, will there be an AI native computing foundation, and will there be a whole different set of technologies than what we're looking at here? Or is it all kind of gravitate back toward the cloud?
I have no idea. I think, it's worth, the CNCF has a definition of cloud native, and, the committee got together and wordsmithed this stuff forever. My definition of cloud native, or at least cloud in general, is that I think cloud is defined by taking things that happen on human time, like allocating infrastructure based on you file a ticket, somebody orders a machine, or does some click ops in a VMware, control panel someplace, and ends up, resolving that ticket. And you move to machine time, where all of a sudden something that used to take 2 weeks now takes 2 minutes. And that fundamentally changes how you operate when you move from human time to machine time. When I look at AI, I think that there's a movement from deterministic but limited to unpredictable but expansive type of thing, right? And I don't know how that's going to play out, right? So there may be
unpredictable yet expansive, meaning these massive AI factories that have
it can surprise you both in good and bad ways, right?
Yeah.
I think everybody looks in LM and they're like, holy crap, I can't believe it came up with that.
Right.
Both in a good way and also in a bad way, right? And I think we all know that, my model for LLMs is that they're neurodivergent, but they're neurodivergent in a way that we haven't experienced before, right? Not in a human way, but in a machine way. And so how that applies to infrastructure and how we use that in infrastructure is something I think we're still figuring out. So I think we're still too early to figure out if there is a AI native compute sort of, combination here in terms of what this looks like and where it's useful and how we use it. I suspect that there's something there. I don't know exactly the shape of it. So I don't know if you guys have other opinions here.
Not much other than the cloud really being a key piece of enabling that higher level of AI and inferencing and making an API that's not deterministic anymore, but just gives you a rough direction of what you want. Maybe interprets a few things, and again, good or bad ways. Yeah.
Hasibul, you want to make a prediction?
In my mind, I think this is the same thing that happened with the containerized and non-containerized workload. So the basic thing changed, thanks to Joe and other people. Like when things are able to get containerized, things becomes portable, and that actually give birth to cloud and a lot of the things we are seeing today, including cloud native foundation. So in my mind, when the AI, this is the first generation of the AI, and this will go away in next to 2 to 3 years. And the new generation of AI that is emerging, that's called causal AI. And technically they are in the same Gartner hype cycle in year 2022. So we get super hyped into the LLM and less hype into the causal AI or spatial AI. So it's difficult to build, but it will take another 2 to 3 years. I think that will take over. That is a more grounded, and then LLM will sunset ultimately, non-deterministic thing. So it will be only applicable to generative way, but people will, people who run the business and see the actual outcome of that one, these non-deterministic things will more and more kind of only be used in a generative way. So it's a very difficult to put the a generative AI into the kind of line of business because your outcome is a non-deterministic.
I'm not going to make any predictions, but I will make an observation, which is, when I first started Hedgehog, and you're going through sort of your marketing terminology, and you're developing your vocabulary for how you describe the business. I was really hesitant to use the word data center anymore, right? Because it was such an old, like, 90s thing, and everything was cloud now. And so the thing that I've observed in 3 years of doing this is all of a sudden infrastructure is cool again, right? I mean, you can turn on just the nightly news and hear about AI data centers, right? And then you start learning all of the stuff that goes into making a cloud, and then you see how rapidly it's evolving with new infrastructure requirements for new types of AI. I think you just talked about causal AI, which now I got to go think about. So I just think it's a super exciting time. I think it's a great time for anybody who's here, who's part of the Linux Foundation or the Cloud Native Compute Foundation, who's curious enough to get under the hood and learn more about infrastructure and how things work, that there's just a tremendous amount of opportunity for everybody to innovate and have a really good time doing it. And so on that note, let's give it up to questions for the audience. Anybody have any good questions? And I'll pass the mic.
It's wired, so I don't know how far it can go.
You might have to come up. Somebody? Anybody? Come on. It's Ganesh, right? Yeah. And with Microsoft, right?
Exactly.
All right, here you go.
Great panel, by the way. Love the ideas you shared. I was curious about your company and how you're simulating basically infrastructure changes and simulating that environment.
Think about more or less is a self-driving car. Easy way to visualize it. And we are applying this similar algorithm to the infrastructure changes. That means you are in a point X, another thing is point Y. So both of things are changing, right? What will change if you make that changes? So think about you are in the intersection, another car is coming on our way. And then how the CORL work, self-driving car behavior, is similar. It's a series of events.
So I guess go ahead.
So that's how like the actual prediction algorithm works.
So for self-driving cars, for training the algorithms, people create like simulation environments to mimic basically the real world and then replicate that. So I was curious, what is the type of, what are the elements for mimicking that for distributed systems?
We are not LLM.
Yeah.
We are not, LLM is just a NLP layer. So technically, if you think about what you are asking is you are asking a different question. The first question that you are asking, how you replicate the road map.
Yeah.
And second question that you are asking, what is replacing sensor? That means when you drive a car, you have without Google Map, no self-driving car will be happening, GPS. And without a sensor, LiDAR technology, there is no self-driving car. So that map back to when you are mapping something. So we already built a knowledge graph for a long time that exists. You can map your infrastructure and topology. Second thing is mostly all the infrastructure, all the observability tool that exists for last 10 years. Advanced of the cloud, that's your sensor. So if you map them together and you have a knowledge base, and that knowledge base is basically giving you the current state of the environment, and if you put it together with the past incident history and all the code and things, you already know your past. So if you know your past and present, so you could predict that how you are going to the futures. And that becomes your time series information. And if you think in that way, so ultimately you can build a prediction trajectory engine. And then you could, ultimately everything is like that. So you have past, you know your present, so you could predict the futures and you could have a multiple direction of the futures and you could actually come up with a simulation outcome. And people can pick, you can have a decision tree. So basically you have option A, option B, and option C. And it's ultimately human decision, what decision they're making.
Got it. So you have a knowledge base and like knowledge graphs of different components. And then you're using real-time data from
Yes,
these
that's a
services,
sensor.
and then you're making predictions based on
Yes.
that. Cool. And it sounds like you don't simulate stuff. There's like not an environment that exists which simulates this distributed system.
It does. So it's called graph mutation. So basically, if you have the question that you are asking, can I intercept the developer code in a VS Code on GitHub? And that's your future state of the environment.
Yeah.
And that's how the self-driving car predict that if I am crossing this intersection, something else is coming. You might have a two PR getting merged at the same time, they could create an outage. So that's the predictions we make. And that's actually, the reasons we are a developer tools. Basically, we want to be a VS Code extension or GitHub bot. So that actually not only look into your PR, it also look into the real-time environment. It can look into the other thing getting deployed and basically make a prediction so that, okay, so if you do this, then, oh, there is a 3-car coming, you will have a 3-car accident.
Got it. Yeah, thank you for sharing. I'm actually speaking about AI infrastructure, like AI agents for AI infrastructure tomorrow. So I was very curious to hear your thoughts. Thank you.
Thanks a lot.
Anybody else? Yep.
Thank you. So I learned a new term, the AI native, tonight. So, so that's already a win. So I've been pushing my company for cloud native, and we'll get there one day. But in the AI native landscape, is it at the edge or in this 90s data center?
It's interesting. I think when you're operating at the edge, fundamentally, there's not enough room for everybody to do everything they want to do, right? And I think when we think about AI at the edge, we all talk about LLMs. I think we're gonna, I'm not an expert. I'm not going to pretend to be, but I think there is definitely a tilt towards small language models, right? How do we start taking this knowledge and actually shrinking it down so that we can prioritize latency over correctness?
Right.
And I think that there's a time and a place for problems that require low latency and where operating at the edge makes a lot of sense. And there's problems where you want to think harder and actually moving stuff towards more central data centers with more resources makes a ton of sense. So I think anything like this, it depends, or it's both, right? I think ends up being the answer there. So it's not very satisfying, but I think that's where it's at. Yeah.
We got some real world examples here. So Florian.
Yeah, you guys do a lot of low latency. Timing matters. Yeah.
Yep.
In the case of Zipline, what's the edge?
Our edge is literally the aircraft in the air. We're flying offline.
That's not a 90s data center.
No, it's not. It's not. It is a teensy tiny data center. We have like 3 compute models that are capable of. They have some tensor cores, and they do inferencing. They run object detection, semantic segmentation to control the aircraft. Like 50 milliseconds later, I need to go left and then not crash into whatever, right? Or, oh, this is a flat surface, but it's shimmering, so I guess it's a pool. You don't want to have your burrito delivered into the pool, right? You want to have it right into the grass. So that's our at the edge. And I think what's helpful, or like just the nature of it, is with each aircraft you have one more compute platform, right? So you both use it in action, like while it's in the air, you make all these decisions, but you got to charge, right? So you sit in your dock, it's idling around. Why not use the compute to actually go through your log files, whatever you just collected during the flight, reprocess it, check for errors, like do some stuff with it, right? These are the 2 edge use cases that we have, and it's.
So you've got edge at the stores where the drones dock, in addition to the edge for the.
It's the same edge,
yeah.
But it's one edge that is kind of.
It's a mobile edge.
Hard real time, having these models in the loop, and then there's kind of this more like batch processing workload that you can do while you're docked and while you're recharging. You can still use your compute, right, and do some number crunching with it.
So does containerization play a role in distributed edge compute?
In our case, it's not a part of it for certain concerns, but I'm a proponent of this idea because some other famous billionaire thought about that his cars could be the next kind of cloud environment, and then pushing those container images, like you have, I don't know, 100 million, not that many, 10 million compute nodes sitting around, and just use 1% of them. Give them some jobs to work on, and containers are, I think, the ideal use case for that. You can package your container with the data that you want to process, and then just crunch the numbers. If it fails, like, I don't care. Like, the next one will do it. It's just an opportunistic way, and definitely something that makes total sense. Yeah.
Thank you.
I'm curious, what do you perceive to be the hardest challenges or headaches running AI in production, whether it be predictive, generative, or maybe even people?
In our case, one of the challenges is to get a balance of, okay, you have a lot of data that's expensive to store, expensive to collect. You have another variable that is how much cost you want to put, or how much budget you want to put into training. And then this is how you control the outcome, right? So you put a lot of money into training, put a lot of money into data acquisition or running data collections, and then you come out with something. And then this, plus the factor of keeping track with current technologies and then keeping everything up to date and have smart people around you to actually create a product out of this, and then that's capable of flying, that's capable of making those decisions in the air. That's a challenge. Like, you want to be really on top of getting the best out of this, because in our case, there's no infinite income of money, right? We need to be frugal with what we have. So tuning these things, and in our case, that's my job, is making sure that the company doesn't suffocate from AWS, sorry, not supposed to call any names, but from cloud billing, and go a more like reasonable and much more cost-efficient approach. So I'll make sure that we have the compute that we need to do the job that the engineers want to do.
I think authentication authorization is the largest problem we have. I think so much of what we've seen of AI is trained and operates on public data. It's like Google, right? Which is great. But so much of the value is around private data. And we don't have a good way to make sure that if you train models on private data, it doesn't taint those models. I participated in, Facebook invited me to tour one of their data centers in Oregon 5-8 years ago, something like that, and talked about how they, at that time, used machine learning models, because nobody called it AI at that point, right? It hadn't, hit that point. And then you had those machine learning models for serving advertisement meet GDPR in Europe, right? And so somebody says, forget me. What does that mean when that identity gets baked into the model, right? So that's one example, but I think there's so many examples of like the promise of AI is operating on private data, but we don't know how to segment and actually protect that in a real way. And I think a lot of the mechanisms we have for humans don't apply when you're operating on machine time. It's that sort of like human time versus machine time. Like, I think the authentication authorization that we have for humans, it just doesn't scale when you're operating at the sort of latencies and rates that you get when it's AI driving the bus.
So does that mean that we all just need to be really concerned about our privacy?
Yeah. But also, I think, you got to weigh the privacy versus the utility, right? There's utility there, and also how comfortable would you be pointing AI at your Gmail inbox, right? It's like, I don't know, that's the core of, like, there's a lot of private data in there. I'm like, now expand that to a corporation trying to figure out how to use AI, right? They know if they don't start using AI, they're not going to keep up with their competitors, but they also know that there are crown jewels data that they have to actually protect, and they don't know how to balance those things. And I think that's a real challenge that we're facing right now.
I echoed Joey. I think the biggest problem with the AI is we did not figure out how to do a privacy preserving AI. And only few companies in the world publicly talked about it. Apple is one of them. And there is not enough money into that space actually figuring out the responsible AI. And then second big problem is there is also the data that AI preserves, the sort of architectures and everything. There is not enough attention into there that actually what is considered PI and how to categorize the data, what is not available to the people, and kind of like a same thing apply into your storage, right? Online storage and offline storage, you can categorize the data, but AI does not distinguish. Everything is the same for it. So I think it's a matter of time. Like a few places it happened already. I think one of them is one of the airlines, right? Their customer data is getting exposed. So I think the biggest problem, I was from the Uber and we are from front of using AI into all our production system. So GenAI or LLM is not the right product to apply everywhere. And then there is a hype in the industry, including all the engineers, to throw LLM into the everything. And I think industry will kind of come into a middle ground that there will be a mixture of like a different kind of AI model that's emerging. And I think we are not there yet.
Yeah. I'm curious, is anyone running agents in production? You have any use cases for that?
I know a lot of people running agent in production, but based on my experience, the successful use cases treat the agentic workflow as a very deterministic workflow. And two things is very highly required to make it works. One thing is you need to have a data cleanup. That means the data that agent is processing is highly correlated. Second thing that is need to be kind of, you need to ground it. That means you need to treat it as a database call, as a eval. That means that all the data it is processing, you knows the output, right? That means you know the confidence level is that actually AI giving you the right answer or wrong answer. It is not making up the answer. And it is still, industry still, eval is a very new thing for Gen AI. A lot of the startup doing eval, but I still figuring out with all the new startup I'm seeing every day, which one actually works in production.
I mean, who's evaluating the evaluation LLM, right?
Huh? So evaluating means that if you think about you are dealing with a non-deterministic entity,
Yeah.
so only way you know that non-deterministic entity giving you an answer with a baseline, you have to score it, confidence score. And confidence score need to be in between 0 to 100 if you assume that. That means you have enough sample manual use cases. You know a lot of the people in Kenya, all the peoples they are working on. So you are throwing those manual use cases on it and you are ranking all the output in a range. And then next time you are getting an output from the Gen AI, you actually confidently give it a score saying that, okay, based on my past, all the grounding work, the output I am getting is fall into this range so that it actually works or not work. And that is going back to that productivity problem. Yeah. AI is supposed to give us so much productivity, but to make AI work, you need to have so much manual grounding data. That means you need to go back to basic again. Mm-hmm. So this, I think that's the biggest problem. The places I know that have successfully deployed the AI agent, they figure out those two things, that the workflow is they know this workflow, they can process this data, and they also have a very clean data, so they can actually generate the evolve very kind of deterministically, that the answer that AI agent is giving, they know that it's actually right answer or wrong answer.
So you're saying using LLM as a judge, but you also need to make sure that that tool that's LLM as a judge is also working well.
Yes. It's not LLM as a judge, it's mostly
evaluating accuracy, toxicity.
There is a recent blog post from Ankur Royal. He is the Brain Trust CEO.
Oh yeah, Brain Trust.
And then I'm a good friend of him, and he has a very strong opinion, and I also has the same opinion. That means you have to treat LLM as a database call. That means you know that what you are expecting. If you don't know what you are expecting, the result you will get is not will make you happy.
So you're trying to put a deterministic cage around a non-deterministic
entity.
Yeah,
that is the most difficult things to deploy an LLM.
Yeah.
We do that with humans every now and again too, don't we?
Thanks.
Yeah, we do that.
Sorry, I think I asked a couple questions.
We put guardrail on everything, right?
Yeah.
So.
Yeah. Cool. Thank you. Sorry.
Any other questions from the audience?
Any questions from one more person? Anybody has?
I think you had a question in the back, right?
Thanks.
There you go.
So I'm going to ask a networking question, but it's going to be an easy one. Well, maybe not easy. Suppose that we embody our AIs with robots and now we're letting them run autonomous. What does the networking protocol look like that they use to communicate with each other so they can all work as a swarm as we start to scale that up over a large amount of robots and workloads and so on? So that's the basic question. Because what does that look like?
Okay, so robotic, machine to machine, of basic network protocol. Is it going to be TCP/IP or is it going to be something else?
Like, I assume it's maybe. I mean, I assume it's not going to be streamable HTTP over quick. It'll probably be something else. But like, what are the properties you think it would take in order to make that work?
Yeah, I don't know. That's a good question. I mean, I spent a little bit of time in IoT, where you got a lot of different devices that are on cellular networks. It's all TCP/IP, but I don't know. These guys are working on robotics at a much larger scale. What do you guys think?
I'm just grabbing the mic to say I have no clue. My daughter is 17 and working on the high school robotics team, so it doesn't really come into play. I do think that the terminology I've been using is hard code versus soft code, right? We have hard code, which is human tested, reviewed, deterministic stuff, and then AI, LLM stuff where it's like, I don't know, maybe it'll do something I want it to do, right? And I think we're seeing sort of this sort of like layer cake of hard code and soft code and hard code. And I think once you start dealing with the network, I think we need hard code there. I think it's going to be, thinking about soft code over the network is interesting. And I think when we start looking at some of these sort of MCP, sort of like we don't know what we're talking to, but we just give it plain English type of things, maybe that'll eventually play out. But I think we're going to see much more deterministic stuff over the network and have sort of higher level planning type of stuff maybe be done via soft code. But love to know what you think.
Oof. I want to start the same way. I have no idea. Just from my gut feelings, I think of it similar to what we do with service mesh, right? Mm-hmm. Where what are the properties why do we introduce service mesh? And those are like individual pods and services that want to talk to each other in a secure way. Like that's the first thing. Like you want to have things like MTLS, right? You want to be sure that you know who you are talking to and that there's unmodified. And I think the same principle is for any robot that's running around the street. And like what is the command and control pattern? How do you make it secure? And that's the whole hard code stuff, right? You don't want to have any ambiguity whether or not the communication is safe or not. Other than that, I just said IPv6 because I saw that XKCD meme where the world is eaten up by nanobots and then they stopped at 2/3 of the world and then the ISS is thinking, well, what happened? And then you see one bot took to the other one. We should have switched to IPv8 like a year ago. So because you had like too many, they ran out of IP addresses. So yeah. But other than that, our drones communicate, like we will get into a similar problem at some point where you need drone-to-drone communication for deconfliction, but we already have that. In our case, we use, I think we talked about it, we use kind of the parts of the Wi-Fi standards to talk to each other. And then there's also the kind of the central hub communication, like what do I do? Like where to go next, right? These kind of things. And we scale, the goal is to have tens and hundreds of thousands of drones in the air at some point. And I'm happy to relay that question to our team who's thinking on and knows much better what are the challenges about this. And like things like congestion. You can't have like, I don't know, 1,000 drones up in the air, kind of putting a lot of pressure on GSM or G5 communication. That needs to work somehow. They can't have their Starlink dish with them. It's way too heavy like this. Definitely some challenges ahead of us. Yeah.
But it's fair to say that if you've got thousands of drones over our heads right now, and you have a lot of network latency or congestion, or worse yet, a network failure because you're using some sort of fuzzy logic to control the network, that it might not be a good situation.
So in any case, you need to have these hard logics, these human-defined behaviors for these situations, like the deconfliction, you don't want to have them crashing, right? You want them to figure out what's going on, and this always has to work. And you want to be really careful in what you're doing, and make sure that you have like that this goes into the validation and whatever, like simulation and stuff like that. But really make sure that if everything, like if the city loses, is a blackout, right? The power is down. What do? Like you can't just give up and then just park the drones, right? It's not a thing. And these are the challenges. But I'm pretty sure we'll find a safe and secure way to do this.
Cool. Thank you.
All right, so that's it for the formal discussion. Please have some more food and drinks and have really good discussions amongst yourselves and with us. Thank you for coming.
Thank you so much, everybody, for coming. We have a lot more pizza. They just put more on that table. We got more in the back. And I just want to give one more special thank you to Menlo Park Patents. If you're looking for a patent, let me know. I'll connect you. And then our chair, who is helping you save on cloud costs. So yeah, and one last thing. At 161 Ventures, when we first started hosting events about 9 years ago, I was a student in college. We would always say this one quote, which was, if you want to go fast, go alone. If you want to go far, go together. So with that, let's mingle. Let's get to make some good connections. And as you're networking, go up to somebody new that you've never met before. Ask how you can help them, right? What can you bring to the table? A lot of people come to these events with an agenda of who they're looking to meet. But what I found is if you go with the perspective of how can I bring value to somebody in this room, it makes it so much more valuable for everybody in the room. So yeah, let's have some good drinks, let's have some good food, and let's have a good time. Thank you for coming.